Hello everyone. Today we are going to discuss the topic of recursion. Let's start with the definition of recursion. Recursion is a type of function that calls itself. Like recursion is like any other function, but the difference is in recursion it calls itself. It breaks down the problem into simpler manageable units and solves the problem. Like when there is a big problem, it breaks down the problem into simple units and combines them to solve the problem. And it is a fundamental concept in computer science as it provides elegant solutions to complex problems. Every recursion must contain the following two things. First thing is a base case. A base case is a problem that is already solved. Like a base case is a problem which does not need any condition, it is already solved. Whereas second important thing is recursive case. Recursive case means the function calling itself. A broken down problem which continues to break until base case. It follows some conditions. According to the conditions, it calls itself and it repeats until the base case is reached. Now let's see how recursion actually works. Recursion works by maintaining a stack where each function call is pushed into the stack until base case is reached. As you can see in the figure down, the bottom of the stack contains the main function, and when the recursive call one will be pushed into the stack, and then recursive call two, and it continues. This process continues until the base case is reached and all will be traced and it returns the final solution to the main function. Now let's see some differences between recursion and iteration. You may think what is difference between iteration and recursion? Both do the same thing, that is repeat a task. So let's see the main differences between them. First, let's see iteration. In iteration, it repeats a step continuously until given condition, whereas in recursion, the function calls itself repeatedly. In iteration, the main difference between iteration and recursion is iteration executes in the main function itself. It does not require any additional memory, whereas recursion creates its own memory. That is, as we have seen before, the stack. Iteration is suitable for simple repetitive tasks, and iteration uses less memory and time. As it executes in the same main memory itself, it of course it requires less memory and time. Whereas recursion, there is a disadvantage that it uses more memory, of course. And there is a disadvantage in iteration as well. That is, iterative statements can be lengthy for complex problems. One advantage of recursion is it improves readability, like it is understandable by anyone. So these are the key differences between recursion and iteration. Now let's see some basic examples which are being solved using recursion. The first one is telling us to solve factorial of a number using recursion. Now let's see the program here. We have declared the header file and int fact int n. Here the fact is recursive function, and int n we have took argument the number, and if n equal 0 and n equal 1 or n equal 1, return 1. As we know, factorial of 0 and factorial of 1 both are 1. So those are base cases that does not require any other function calls. It is already solved. Else return n into fact of n minus 1. Like, for example, 5 factorial can be written as 5 into 4 minus 1 factorial, and so on. So we return n into fact of n minus 1. That is n into n minus 1 factorial. So this is the base case, and return the else return statement is a recursive case. Now let's see what is with the main function. We have declared a int variable p, and we took input from the user, and we printed the factorial, and here is where in the printf statement we call the function. We can call the function outside also, but I called in printf statements itself. Now let's see the output of this code. Let's see the first test case. Enter number 6. Though it return factorial of 6 is 720, which is true. Let's see the second test case. Enter a number 4. Factorial of 4 is 24, which is also true. Hence our code works, and this is the example of factorial using recursion. Let's see the next example. It is telling to calculate power of a number using recursion. Power means, as you know, like it contains base and exponent, like 7 power 4, 2 power 3, like that. And let's see the program. Header file is there. Int power. Power is the recursive function that we are using. We took two arguments, x and n. X is the base, n is the exponent, like x power n. So inside we declared if n equals 0, return 1. As you know, anything power 0 equal to 1. So this is the base case, which is already solved. Else return x into power of x comma n minus 1. For example, 5 power 4 can be written as 5 into 5 power 3. Similarly, it returns x into power of x minus 1. That is x into x power n minus 1. So this is the recursive case. Now let's see what with the main function. We declared two int variables, we took the input and we call the function power p comma q. So it goes in the function and returns the solution again to the main function. Now let's see the outputs of this code also. First case, test case. Enter base and exponent. We have entered 20 and 2. So our intention is we have to find 20 power 2. So it returned 20 power 2 equal to 400, which is true. Now let's see second test case. Enter base and exponent. We have given 7 power 3. So in our mind it's running that we want 7 power 3. So it gave 7 power 3 is 343, which is also true. So this is all about recursion. Recursion, this is just a basic recursion. Recursion is used in many other programs also, like linear search, binary search, and in many complex programs also. This is the basic recursion. It is very important topic in data structures. Thank you. I hope you understood.